Hello, so today we are graphing quantitative data with box plots. We've graphed quantitative data with dot plots and histograms so far, but today we are graphing with box plots. This corresponds to section 1.3 in your textbook if you would like to go there for more examples and practice problems. So in order to make a box plot, we need what's called the 5-number summary. The 5-number summary are the 5 main values used to describe a distribution. They are the minimum, Q1 is the first quartile, the median, Q3 is the third quartile, and the maximum. If we think about a quartile, think about a quarter. A quarter is 25 cents, so Q1 is the 25th percentile. 3/4 would be 75%, or the third quartile. So quartile is the same idea. Box plots give us a quick description of the center and spread, which is really helpful when analyzing a distribution. And the 5-number summary is used to make box plots. You've seen box plots before, but just to review, the minimum is the lowest point, Q1 is the edge or the lower edge of your box, the median is the midpoint, Q3 is the upper edge of your box, and the maximum is the highest point. So we're going to be making a lot of box plots in this course, and today is an introductory lesson on how to make them and analyze them. So key point number 1, the 5-number summary gives us the information needed to make a box plot. It tells us the minimum, lower quartile, or Q1, the median, the upper quartile, or Q3, and the maximum. So how do we make a box plot? An example that we are going to use today, remember, for the examples we use today, you want to make sure that you get these numbers in your notes. It says here are the number of apples eaten by students in 1 month. So we're given a list of 7 numbers. I was going to say 9, 7 numbers. The first step is to put data in increasing order. So I took these 7 numbers and I rewrote them in increasing order. That is the first step. The second step is to identify the median. Once the numbers are in increasing order, the median is going to be the middle number. 9 is the middle number. There's 3 numbers below it, 3 numbers above it. So 9 is my median. Well, then I want to find the first quartile. Well, the first quartile, or Q1, is the lower quartile. So what I do is I look at the bottom 3 numbers, or I should rephrase that, I look at the numbers below my median. My median was 9. The numbers below my median are the lower half of my data. The first quartile is the middle of that lower half. So 5 would be Q1. It's the middle of the lower half of my data. The third quartile is the middle of the upper half of my data. So since 9 was my median, the upper half of my data are these 3 numbers, 10, 13, and 16. 13 is the middle of my upper half. The middle of my upper half would be Q3. Once I have those, you are ready to graph. So, just to review, the minimum is where I have my first line, or where I begin. The minimum is 2. My first quartile, we said, was 5, and that is where my box is going to begin. So I connect my minimum to my first quartile with a line. My upper quartile is 13, so I'm going to make that the upper end of my box. My maximum is 16, and then my median is 9. So this is a graph of the number of apples students eat in 1 month. I start with my minimum at 2. I connect my minimum to Q1 with a line, and we can label these two, Q1. My median is the middle of my data, which is 9, and it's a line going through my box. Q3 is 13, and it connects to my maximum, which is 16. This is a complete graph of a box plot for that data. But what if we think that there's an outlier? So we've seen outliers before. We've seen them in different examples, and we've inferred that they're there. But what if I want to know, is there an actual outlier? So make sure that you get this information down. The outlier rule is super, super important. So the interquartile range, or what we call the IQR, is Q3 minus Q1. This is the middle 50%. And it's the box. The IQR is just the box in my box plot. Well, we call a value an outlier if it is more than 1.5 times the IQR, above Q3 or below Q1. You will see a tangible example of this in 1 minute. You just need to get this information down before we move on. So the formula, this should say anything below, oops, typo. Anything below Q1 minus 1.5 times Q3 minus Q1 is an outlier, or anything above Q3 plus 1.5 times Q3 minus Q1 is an outlier. So let's tangibly see what this looks like. Key point number 2, to test for outliers, we use the 1.5 times IQR rule. You will see it written like this. This is the outlier rule. So make sure you know what this means if you see it in your textbook or in this class. Any value in our data set above Q3 plus 1.5 times the IQR, or below Q1 minus 1.5 times the IQR, is an outlier. So what if we had someone who ate 30 apples a month? What if we had someone who ate an apple a day? If I wanted to use this example, this is a new example because I have this person who ate 30 now instead of 16. The median of this data set is still 9. It's still the midpoint. 9 is the middle. It has 3 numbers below it, 3 numbers above it. So my median is 9. Q1, which is the lower half of my data, the middle of the lower half is 5, so Q1 equals 5. Q3 is the middle of my upper half. Well, my upper half would be those 3 numbers, and 13 is still Q3, or the middle of my upper half. So now if I wanted to find if there were any outliers, Q1 minus 1.5 times Q3 minus Q1 is the formula that I use to calculate lower outliers. Well, Q1 is 5 minus 1.5 times Q3, which is 13, minus 5. So that would be 5 minus 1.5 times 8, which is 13 minus 5. 1.5 times 8 gives me 12. And 5 minus 12 gives me negative 7. Since no data value is below negative 7, there are no lower outliers. So there are no lower outliers in this data set, but now we're going to check for upper outliers because we think 30 is an outlier. So let's take a look at the upper outliers and see if there are any. Q3 is 13, so if I do Q3 plus 1.5 times Q3 minus Q1, I have 13 plus 1.5 times 13 minus 5. Well, that would be 13 plus 1.5 times 8. 13 plus 12 gives me 25. Since 30 is above 25, 30 is an upper outlier. So this value 30 is an outlier. Let's see how we graph. If I'm graphing a new data set, remember it's new because we have that 30, my minimum is still 2, my Q1 is still 5, Q3 is 13. I connect Q1 and Q3 to make my box. Remember this box is called the IQR. I connect my minimum to the box with a line. Since I have an upper outlier, need my median at 9. There we go. Since I have an upper outlier, instead of having the line go all the way to 30, I get to put a little star at 30. We always star our outliers. So this looks funny, but this is how we graph it. So how I know how far to extend the tail that's going to come out from here? Well, the tail that comes out from here goes to the next highest point. Since 13 is the next highest point, there's actually no tail that comes here because 13 is also Q3. So as funny and as weird as this graph looks, this is a beautiful and perfect graph of that data set. So if I wanted to describe that data set, remember we describe a distribution by talking about its SOCs. This is review. From before, the only thing that's changed is now I can use my outlier rule to talk about outliers. So if I wanted to do SOCs for the data set that we just looked at and just graphed, the shape, if we look at it, it's skewed to the right. It's skewed to the right because the right tail was much longer because I have this outlier at 30. The right tail was longer because 30 is an outlier. The outliers, 30 is an outlier. 30 is an outlier, and I know that because of the 1.5 times IQR rule. We could even edit this and say 30 apples is an outlier if we wanted to give context. The center, the median, is 9 apples a month. And the spread would be from 2 apples to 30 apples, or the spread would be 28 apples. This would be complete SOCs if I wanted to describe this data set or this distribution. Some of the benefits of box plots, they're good for side-by-side comparison. If we look at these two examples, they're really good for side-by-side comparison. I can compare the females with the males and their haircut cost rather quickly. Also, over here we have unemployment rates in the US, and I can see the difference from 2009 to 2010 and the fact that unemployment shrunk from that year to that year. Boxplots show a quick overview of the data, which is important. It gives us a snapshot, super easy to make if we know the 5-number summary. So a recap, the 5-number summary contains the 5 main values used to describe a distribution. It's the minimum, Q1, median, Q3, and the maximum. Box plots are another way of graphing numerical data. The IQR is Q3 subtract Q1, and it's the box. This is the IQR. It's the middle 50%. That's super important that you have that understanding that the IQR is just the middle 50. It's from 25% to 75%. And lastly, outliers are marked with a star. We don't draw the line all the way to the outlier. We replace it with just a star on the outlier and the tail going to the next highest point. So that's a wrap. Box plots are a quick way to graph numerical data. We use SOCs to describe them and always check for outliers before graphing. Remember, this corresponds with section 1.3 in your textbook. You can always go there for more notes and information. See you later.